Welcome to the development overview of Lucid Hollow, a Capstone project created by Control Freaks Game Studio. This presentation highlights the procedural tools, environment design, and creative workflows used to bring a stylized and surreal game world to life. Each section will break down a specific Houdini digital asset and show how it was integrated into Unreal Engine to build a playable, cohesive environment. To begin, let's take a look at the landscape that forms the core of Lucid Hollow, a stylized, mushroom-shaped terrain that defines both the layout and identity of the world. The terrain for Lucid Hollow was created in Houdini using a procedural height field workflow. The shape was painted to resemble a mushroom, establishing a unique silhouette for the world. After blocking out the base form, nodes like height field noise and distort were applied to create natural terrain variation and break up uniformity. Following the distortion, a mask labeled Temple was painted to isolate a central area meant for a key landmark. This allowed precise sculpting of elevation in that region without affecting the rest of the landscape. The red region represents this mask, used to define and elevate the temple zone. Additional noise, blur, and remapping nodes were layered afterward to integrate it smoothly into the surrounding terrain. The final height field was exported to Unreal Engine, ready for further detailing and gameplay integration. Next is one of the modular assets used throughout the temple area, custom-designed benches built entirely procedurally in Houdini. This tool allows for quick adjustments to the bench's overall length, as well as a toggle to remove specific planks, giving more control over visual variety and wear. The bench tool includes a toggle to switch between a whole and a partial version. The partial setting allows specific planks to be removed, adding variety and wear to the asset. When partial is selected, additional controls appear, allowing for the removal of 1 to 3 planks with a seed value to randomize which ones are hidden. This helps generate subtle visual differences across benches while maintaining a consistent style. The length of the bench is also fully adjustable. The tool scales the base and automatically updates the number of planks to match the new size. The setup is organized into modular sections for the seat planks, side panels, and mortises, making it easy to manage and expand. Decorative details like the mushroom engraving are integrated procedurally to match the visual language of Lucid Hollow. With customizable options and clean topology, this tool supports quick iteration and consistent placement throughout the environment. This Ivy tool was built using the Side Effects Project Titan example as a foundation and adapted to suit the stylized aesthetics of Lucid Hollow. In Houdini, the system procedurally generates Ivy geometry that clings to surfaces, growing organically across walls, beams, and other architectural elements. Parameters allow control over growth patterns, coverage, direction, and density, making the Ivy flexible enough to suit both clean and overgrown environments. Once generated, the Ivy is exported into Unreal Engine, where it adds natural variation and a sense of age and atmosphere to structures throughout the world. Geometry can be input directly or sampled procedurally using the World Input dropdown. Materials for leaves and branches can be assigned directly using relative paths, allowing for flexibility when exporting to Unreal. The base controls offer precise adjustments for remeshing density, starting point distribution, and surface noise. These sliders help define how the Ivy adheres and spreads across the object. For example, the density scale affects how heavily the Ivy populates the mesh, while push-out branches allows tweaking how far the branches protrude from the surface. Branching behavior is managed independently, with control over growth, number of side branches, and hanging vines. These parameters let the Ivy feel either light and delicate or wild and overgrown. Leaf distribution is controlled with its own seed, coverage value, and scale ranges. This creates variation in size and density, helping the Ivy feel natural rather than procedural. With just a few adjustments, the tool can produce drastically different results, ideal for environmental storytelling, whether it's a long-forgotten ruin or a well-maintained sanctuary. Once the IV is generated and exported, it integrates seamlessly into Unreal Engine, enhancing surfaces with life and atmosphere. This next tool was designed to quickly populate environments with stylized mushrooms and rocks. Built as a fully adjustable scatter system, it includes parameters for controlling object scale, rotation, density, and coverage. Artists can also toggle mushrooms and rocks on or off independently, allowing for rapid layout variations. The system is split into two scatter networks, one for the mushrooms and one for rocks. Each has independent controls for density, scale, and rotation, allowing for fine-tuned placement. Scatter coverage can be increased or reduced with a simple slider, and artists can also toggle each asset type on or off depending on what's needed in the scene. This makes it easy to test different layout variations or isolate asset types during level design. In the Houdini viewport, mushrooms are displayed in red and rocks in black, which helps keep things visually organized while working. Random seed values can also be adjusted to quickly generate new scatter patterns without altering the rest of the setup. This flexibility made it ideal for filling out large areas of terrain while maintaining a cohesive, stylized look throughout the project. This is the Staircase Generator, a procedural tool designed for fast and customizable staircase creation. It features parameters for adjusting height, depth, and width, as well as the number of steps, divisions, and a toggle for handrails. This made it easy to adapt the staircases to fit different parts of the world while maintaining consistency. Here's a look at the tool in action. The main controls are organized into sections for staircase dimensions and structure. Adjusting these sliders updates the model in real time, making it simple to set the height, depth, and width, or to increase the number of steps and divisions for more detail. The staircase bend option introduces curvature to better suit environments with irregular terrain or stylized designs. Finally, the handrail toggle provides flexibility depending on the scene's needs, whether it's a more decorative look or something simpler. All of this is packaged into a single digital asset for easy reuse and iteration across the project. This is the Cliff Generator, a tool designed to isolate and populate cliff regions from a landscape height field, like the one imported here from Unreal. Using a combination of slope masks and custom height maps, the tool identifies steep terrain and procedurally places 3 different cliff shapes to break up the landscape and add stylized vertical detail. The input begins with a height field, typically imported from Unreal Engine using the Houdini Engine plugin. This provides the base terrain data for the generator. From here, a slope mask is used to isolate steep areas of the terrain. These extracted cliff regions are also separated into different classes for more granular control. After the cliffs are extracted, 3 different planar displacement nodes are applied to project custom cliff rock shapes onto the masked slopes. These displacements are then blended together to form a cohesive result. To maintain natural transitions between the cliffs and the terrain, a blend is applied along the edges, with additional erosion details optionally added using height map overlays. This procedural approach ensures cliff formations stay cohesive with the underlying terrain, while still allowing for high customization through exposed parameters. The damage generator is designed to create procedural surface destruction through a user-painted mask. Using Houdini's paintbrush tool, artists can define specific areas of damage. The painted mask is then processed through an RBD material fracture workflow to generate realistic breakage. This method gives full control over where and how damage is applied, while preserving non-destructive flexibility during iteration. The damage generator begins by importing a solid geometry that will undergo procedural destruction. Artists define the damage region by using the paintbrush tool, creating a black and white mask directly on the surface of the object. This gives full control over the location and shape of the damage. The painted mask is then processed through a remap and blur operation, generating a smooth gradient to drive more natural transitions. This mask is used to isolate geometry for removal. A Boolean operation subtracts the masked areas from the original mesh, producing a rough silhouette of the damaged region. To add realism, the exposed geometry is passed through an RBD material fracture node, simulating layered breakage and internal cracking based on real-world materials. Finally, noise distortions and surface displacement are applied, further enhancing the fractured edge and making the damage appear more organic and embedded into the structure. The house generator is a highly adjustable tool designed to procedurally create modular houses with control over nearly every architectural element. It offers parameters to fine-tune height, width, quantity, spacing, and irregularity, along with customization options for doors, windows, roofs, and more. Each part of the structure is broken down into modular sections, making it easy to control and iterate. The roof system, for example, uses a procedural-based shape that drives the creation of shingles. Short and long variations can be toggled by adjusting just a few points. The windows are also highly customizable. Artists can adjust both their vertical and horizontal scale and reposition them to match the style of the house. The door system functions similarly, with parameters for scale, placement, and frame shape. Even the frame detailing can be altered. While it's kept relatively simple for performance, there's flexibility to change the silhouette or adjust texture elements, allowing the user to maintain a cohesive visual style. To support multiple levels, the tool includes parameters for controlling the size and alignment of the second floor independently. This makes it easy to create buildings where the second level extends or narrows in relation to the base. These controls are especially useful when generating entire neighborhoods, as the generator allows for quick layout population while still preserving variety and uniqueness across houses. Overall, the house generator provides a streamlined, artist-friendly workflow for building modular homes that feel handcrafted while still benefiting from the speed of procedural generation. Thank you for taking the time to explore the development of Lucid Hollow. This capstone project reflects a collaborative effort to push the boundaries of procedural design, world building, and storytelling within a stylized game environment. From modular generators to terrain tools and custom assets, each element was crafted to support a flexible and immersive pipeline. On behalf of Control Freaks, we hope you've enjoyed this glimpse into our process, and we're excited to continue bringing this world to life.